We have discussed how to find the sum of an arithmetic sequence or a geometric sequence, but we have not talked about how to find summation other than listing out terms and then adding them together. So there are a few formulas that you can use to find the sum of a series without having to just list all the terms, especially if you are trying to find a large partial sum. If I'm just doing the fourth partial sum, I can write out four terms and add them together. But if I need to do a 20th partial sum, that's going to take a lot longer. So here are some formulas that you need to write down. Make sure that you have your paper in Cornell note format. Pause the video till you get these formulas written. Now notice that on each one of these formulas, we start at I equals 1. So all of your problems you need to check and make sure if we're starting from I equals 1, because these formulas are not valid unless you start from 1. Notice the n in the formulas represents the number at the top of your summation, and that's the number of terms that you're going to be adding up. So we have a formula if you've just got a constant, if you've got I squared, or I cubed. Okay, so we're going to look at a couple of examples of how these formulas work. Before you can use the formulas, though, you need to remove all the parentheses. So if there's any distribution to be done or any squaring, you need to take care of that first. Then you can apply your formulas. So in this case, I would need to write this out as the sum from I equals 1 to 20. And I'm going to distribute the 3i. So I would get 3i squared plus 9i. Okay, now I don't have a formula for I squared plus I, but I can do the sums separately. And I also don't have a formula for 3I squared, I just have a formula for I squared. But if there is a constant in front of that I, then I can just take that to the front, and this is the same thing as saying 3 times the sum from I equals 1 to 20 of I squared. So I can use my formula for the I squared and then multiply that answer times 3. Okay, I'm going to do the same thing over here. I'm going to put the 9 here and then use the formula for the I. Okay. Now, what was the formula for I squared? The formula for I squared said that we were going to take n times n plus 1 times 2n plus 1 divided by 6. So what numbers do I need to plug in there? Well, I need the n, and the n, again, is the number at the top of the summation, the number of terms. So this would be 20 times 21 times 41, 2 times 20 plus 1, over 6. And then again, don't forget about this coefficient in the front. So we're going to multiply that whole thing times 3. Okay, now our formula for I was n times n plus 1 divided by 2. And again, don't forget your coefficient of 9. So I'm going to say 9 times, my n is still 20. So 20 times 21, 20 plus 1, over 2. Okay, now we're just going to multiply this out. You can use a calculator for this part. Okay, I do want to see the work of setting up the formulas. So when I multiply out this first fraction, I'm going to get 8,610. 9 times 20 times 21 divided by 2 is 1890. And then I just add those two answers together, and I get 10,500 for my sum. A whole lot faster than having to plug in all the numbers from 1 to 20 into our original formula and then adding. Okay, pause the video. I'd like you to try this one first, and then we will turn it back on when you're ready to check. Okay, now I don't have any parentheses to get rid of this time, so I'm just going to split this up because I don't have a formula for I cubed minus 4, but I do have a formula for I cubed, and then I do have a formula for a constant. Okay. Now, I know 4 is a constant, and last time we put the constants in front, but you only do that if they are with an I squared, or an I cubed. And again, notice that we did start from I equals 1. Okay, so what was the formula for I cubed? The formula was n squared times n plus 1 squared divided by 4. And the formula for a constant was the constant times n. So let's plug our n into both of these formulas. So we're going to get our n this time again is 12, the number at the top of the summation. So 12 squared times 12 plus 1 is 13 squared over 4. The c is the number the constant that you've got behind the summation. So our c is 4, and then again our n is 12, the number at the top. Okay, so 12 times 4 is 48. 12 squared times 13 squared divided by 4 comes out to be 6,084. So when you add those two numbers together, you end up with 6,132. So the main things to remember in using the formulas to clear out any parentheses, either if you need to square a binomial or if you need to multiply using the distributive property, you've got to take care of that first, and then you can apply your formulas. And make sure that on the summation that the bottom part says I equals 1. You have to start from the first term.